All right, after having a chance to play with the FETSIM and capacitors in the FETSIM, let's talk a little bit about some facts about capacitors, and then we're going to start to explore them more coming up. A capacitor is two conductors that have opposite charge that are nearby. You can have a conductor with a positive charge on it, a conductor with negative charge on it, and you put them next to each other and you have a capacitor. We are going to be really looking at the simplified model of a capacitor, which is called a parallel plate capacitor. The reason why is because E and V are simple for this type of model. It can get complicated really quickly depending on your geometry, so we're going to stick with a parallel plate capacitor for now. As long as you have separated charges, that means you will have a potential difference across the capacitor. If you've got positive charges over here and negative charges over here, you'll have some potential difference between those two plates. We will talk about capacitance in this way. So C is Q over delta V. This is a physical property of the capacitor. The capacitance only depends on the geometry of the capacitor itself, right? So the questions that you're asking yourself here when you're thinking about your capacitance is, how much charge can I put on these conductors? And that will depend on the geometry of the conductors. And then how far apart are the conductors from each other? How far apart, how big is the capacitor, right? Are those plates far apart or are they close by? And that will also change the capacitance. Units of capacitance are a farad. 1 farad is equal to 1 coulomb per volt. A farad is really, really big, so typically in most circuits you will see capacitors that can be anywhere from microfarads to nano to picofarads. So 1 farad is really big. Typically you'll see farads that are much, much smaller than that.